Okay, let's have a look at this. It goes, a length of a rectangle is increasing, constant rate 3. So one of the lengths is increasing at 3 centimeters per second. The width is decreasing at 2 centimeters per second. Find the rate of the area of the rectangle at the instant when length is that and the width is that. Now before we start, let's do a rectangle. I'm going to call that, I'm going to call A is the length and B is the width. So first of all, I know that area. Well, before we start anything, what do I know? The length. This is, I'm going to call that, actually write that length just so that we know that's the length, and that is, I'm going to call that width. Normally I would use L and W, but it doesn't matter. Now, I've been told rate is always respect to time. The dA dt is increasing at 3 meters per second. And I've been told that dB dt, which is the width, is decreasing. Now when it's decreasing, we make it negative, it's going to be minus 2 centimeters per second. So we dealt with that one, happy days. Now find the rate at which the area, change of area, so we need to find capital A, and it's the rate, so it's dA dt, the rate at which the area is increasing when A is equal to, which is the length, 18, and B, which is the width, is 10. Okay, so that's just setting it up. Okay, I know here that area of a rectangle is length times width, which is going to be capital A equals small ab. Right, so we want to find, let's put in the stuff we got. So we need to find dA dt. Now we've been given, now if I did that, dA dt, I've been given A and B, I've been given two variables. So I need to differentiate that with respect to A. Okay, so I need to do something like dA by small a, and then times that by small a by dt. And then I also need to differentiate that big respect to b and times it by dB dt. Roughly something like that is happening with the chain rule. What's going on? Okay, and then we get everything with respect to that. But it's something like that if you have your head on. That's what we're looking at. So let's just, I'm going to rub this out because that's roughly what's happening in the background, and I'm going to show it a bit more explicitly when I clear this out. So what we've got at the moment, we've got A equals AB, and I want to find, now don't forget these length and width are changing respect to time, so they are a function respect to time. So if I want dA dt, I have to use product rule and differentiate them respect to t. So I'll get u equals a, and I'm going to call v equals b. So if I do du dt, I'll differentiate that respect to a, which is just 1, and then I must times it by dA dt to make it respect to a. Okay, and same with this, I do dv dt, differentiate that respect to time. So first I differentiate v respect to b, which is just 1, and then multiply it by db dt to make it dv dt respect to. Then it's product rule, that times that. So I'm going to write it here, dA dt will equal A times dB dt plus B times d, it's just 1 dA dt. So that's what we got, which I stated earlier. Something very similar. Now, once we got that, we got those, and we've been given the lengths at which we want the rate of change of the area. So all we need to do is substitution. To get dA dt, I change A for, at that instant, A is going to be 18 multiplied by dB dt. Now dB dt is, bless you, is going to be minus 2 plus B at that instant is 10, and that's going to be multiplied by dA dB, which is 3. So you can do this with your calculator or without. 3 times 2 times that is minus 36 plus the 30. The rate of change of area respect to time is going to be minus 6. Area is centimeter squared and it's per second. So that means the area is decreasing 6 centimeters per second.